This is the story of how billions of pounds of leftover beer mash, grain already used once by breweries and thrown away every single day, get turned into flour, protein, and snack food before they even have a chance to rot. Right now, inside breweries everywhere, a valve opens and tons of soaked, spent grain slide out in a wet brown wave, dumped into waiting trucks on a strict, unforgiving clock. For as long as anyone brewed beer, that clock has run the same way. This grain has about a day, maybe two, before it spoils, smells, and becomes nothing but a disposal bill. Cities charge real money to landfill it. Landfills, once it's there, quietly turn it into methane. For most of brewing history, that was simply the end of the story. A byproduct nobody thought twice about, because there was nothing else to do with it in time. Then, within the same few years, two completely different bets landed on the exact same idea. One came from two college friends hauling plastic tubs of wet grain out of a homebrew kitchen. The other came from the research arm of the largest beer company on Earth. Neither knew about the other's work. Both decided the same thing. This wasn't waste. It was a small window of time in which a byproduct could still become food, if someone could just beat the clock. Beer is one of the most consumed beverages on the planet, and every liter of it leaves something behind. Brewing roughly 1.9 billion hectoliters of beer a year generates somewhere between 38 and 40 million tons of spent grain worldwide. The soaked, drained husks and kernels left in the mash tun once the sugars have been extracted for fermentation. That single byproduct makes up about 85% of everything solid that a brewery discards. 38 million tons is hard to picture on its own, so put it next to something solid. The Empire State Building weighs roughly 365,000 tons. The spent grain the world's breweries generate in a single year is the equivalent of more than 100 Empire State Buildings, made entirely of leftover beer mash, rebuilt from scratch every 12 months. In the United States alone, breweries produce more than 20 billion pounds of spent grain a year, 9 million tons, give or take, from just one country's beer habit. And that's before counting a single number from the world's largest brewer on its own. Anheuser-Busch InBev's breweries alone generate about 1.4 million metric tons of spent grain every year, more than the weight of nearly 4 Empire State Buildings from one company's taps. That concentration of volume into a handful of giant producers is the direct result of a century of industry consolidation. Belgium alone had more than 3,000 breweries in 1900, and just 143 by 1980. American macro breweries fell from 421 in 1947 to only 10 by 2014. What used to be spent grain, scattered thinly across thousands of small, local operations, is now concentrated inside a small number of industrial giants, each one generating a single, enormous, unavoidable stream of the same byproduct every single brewing day. In Europe alone, brewers generate more than 3 million tons of spent grain a year, most of it moving through the same low-value animal feed channel at a market price of roughly €35 a ton, barely above the cost of hauling it away. Heineken by itself brews more than 240 million hectoliters of beer annually, one of several European giants whose spent grain output rivals AB InBev's. Almost none of that volume was ever destined for a human plate. For most of brewing history, spent grain has had exactly two available exits: get hauled to a farm fast enough to feed it to cattle, or get hauled to a landfill and left to rot. Neither exit required anyone to think of it as food. Both exits depended entirely on speed. Spent grain's real problem is timing. Fresh out of the mash tun, it's radioactively perishable. Fresh out of the mash tun, it's roughly 70 to 80% water, warm, and packed with residual sugars and proteins that microbes find just as appealing as any other food. Left at room temperature, it starts breaking down within 24 to 48 hours. Past that window, it isn't a byproduct anymore. It's a smell, a liability, and eventually, a bill. That bill is not small. Brewers in New York City alone paid close to $1.9 million in a single year just to have their spent grain hauled to landfill at rates north of $300 a ton. One case on record put the cost of landfilling roughly 6,000 tons of spent grain at $1.2 million for a material that, days earlier, had been perfectly good grain. And landfilling doesn't make the problem disappear once the truck leaves. Buried spent grain decomposes without oxygen and releases methane. And landfills as a category are the third largest human-caused source of methane on the planet, responsible for roughly 18% of global anthropogenic methane emissions. The default fix, where breweries can manage it, is animal feed. Mostly cattle, since ruminants can extract real nutrition from it. But even that solved outlet has real limits. Spent grain converts into about 71 to 75% total digestible nutrients for livestock, compared with 88 to 90% for straight corn feed. And recent research on dairy cattle caps its safe share of the diet at around 20%. It's a useful supplement, not a complete food on its own. And feed only works at all if there's a farm nearby willing to take a wet, heavy, fast-spoiling delivery on short notice, every single brewing day. Small and urban breweries, packed into cities with no working farmland close by, often have no real feed outlet at all. For them, the only two exits collapse down to one: pay to landfill it and hope no one asks what happens next. Part of why this problem sat unsolved for so long is basic thermodynamics, not neglect. Pulling water out of wet grain by evaporation takes more than 4.5 megajoules of energy per kilogram, no matter who is doing the drying or when. Conventional heat or freeze-drying equipment capable of handling that load is expensive to buy and expensive to run. And for a byproduct nobody was paying for in the first place, that math rarely closed. For most of brewing history, if a farm nearby would simply take the wet grain off a brewery's hands for free, running an expensive dryer to turn it into something shelf-stable made no economic sense at all. The fix wasn't a mystery so much as a cost nobody could justify paying. It started in a UCLA frat house kitchen. Dan Kurzrock began homebrewing beer as a freshman, and every batch left him with 15 to 20 pounds of spent grain he didn't know what to do with. He noticed it looked, smelled, and tasted like hot cereal, nothing like trash. Digging around, he and his college brewing partner, Jordan Schwartz, found that a handful of microbreweries around the country were already baking bread out of their own spent grain. So in 2011, the two of them started doing the same thing, selling beer-based baked goods at farmers markets with a modest goal: make just enough money to keep brewing beer for free. Their first batch of bread came out that year. Their first nutrition bars followed in 2012, sold under the motto, "Eat beer." They didn't go full-time on the idea until late 2016. 5 years of farmers market bread and side-hustle granola bars before spent grain became an actual company. In 2014, while still in graduate school, Kurzrock cold emailed the USDA's Agricultural Research Service outpost in Albany, California, laying out the scale of the problem and asking if anyone there could help. Someone could. Over the next several years, Kurzrock, Schwartz, and USDA researchers co-developed a patent-pending thermomechanical process that could stabilize soaked spent grain into a dry, shelf-stable flour before the spoilage clock ran out. No refrigeration required afterward, no off-flavors from the beer it came from. They named the resulting ingredient Supergrain Plus, a flour carrying roughly 3.5 times the fiber and twice the protein of standard whole grain flour, with every pound processed said to prevent the carbon dioxide equivalent of burning a pound of coal, and to save more than 300 gallons of water compared with growing the equivalent grain from scratch. Their company, Regrained, built flour, snack bars, and eventually pasta out of that ingredient. In 2018, it became the first product in the world to earn Upcycled food certification. The same year, Kurzrock and Schwartz were named to Forbes 30 Under 30 and closed a $2.5 million strategic financing round led by the ingredient company Griffith Foods, with Barilla's venture arm BLU 1877 also investing. A homebrew hobby turning into a supply deal with one of the largest pasta makers on earth. At almost the same time, on a completely different scale, an idea with the same starting point was taking shape inside Anheuser-Busch InBev, the largest brewing company in the world. The concept had been floating around AB InBev's research center in Belgium since 2013, championed by a company sustainability executive named Greg Belt. It took 7 years to go from idea to product. In January 2021, Belt launched Evergrain, an AB InBev-backed venture built to do at industrial scale what Regrained had proven was possible at a garage hobby scale. Turned spent grain into a food-grade ingredient, not a farm delivery or a landfill fee. Evergrain's first product, a high-protein ingredient called EverPro, is built specifically for protein bars and plant-based milks, drawing on a fraction of the 1.4 million metric tons of spent grain that AB InBev's own breweries already produce every year. Like Regrain's flour, Evergrain's ingredients earned Upcycled Food Association certification of their own. 2 teams, no coordination between them. A garage-scale food tech startup and the internal venture arm of the world's largest brewer arrived, within roughly the same handful of years, at the identical conclusion. The clock that had always defined spent grain as waste could be beaten, and once it was, the waste turned out to still be food. Within a few years of Regrained and Evergrain proving the concept, the idea stopped being rare. By the mid-2020s, at least 9 separate companies worldwide were milling their own version of upcycled spent grain flour. Names like Biosol, Rise Products, Grainstone, Co-Rise, Grain for Grain, Saving Grains, Ramen Tesdrecious, Ground Up Eco Ventures, and Susgrainable, alongside newer entrants like Rhode Island's Our Grain. Grain for Grain went a step further than sourcing grain from many breweries at once, building a dedicated mill in Texas and working with brewers to put processing facilities directly next door to the source. Their products don't even agree on a single nutritional profile. Fiber content across the field ranges from roughly 30 to 46%, protein from 18 to 30%, depending on the grain, the beer style, and the process. What had looked, in 2013, like 2 unusually persistent teams chasing an overlooked idea had become, within about a decade, a small but crowded industry. None of this was an obvious bet going in. For generations, the entire food industry treated a brewery's leftover mash as a settled question. It was either cattle feed or trash because it was wet, perishable, and had already given up its usable sugars to the fermentation tank. Asking a food scientist in the 2000s whether spent grain could become a stable, palatable, sellable human ingredient would, by most accounts, have gotten a polite version of no. The economics of collecting, drying, and processing a material that starts rotting within 2 days looked, on paper, like more trouble than the leftover grain could possibly be worth. The skepticism didn't get argued away. It got out-engineered. Supergrain Plus's fiber and protein numbers spoke for themselves once the ingredient existed to test. And when Anheuser-Busch InBev, a company with no reason to chase a marginal ingredient business unless the economics actually worked, spent 7 years and real internal resources building Evergrain from a research center idea into a certified commercial product line, that was as close to an industry admission as this space was ever going to get. The waste had been solvable the whole time. Nobody had simply built the fast enough process yet. Even now, the doubt hasn't fully disappeared. Researchers tracking the wider upcycled ingredient space still point to real, unresolved friction. Inconsistent raw material composition from one brewery or beer style to the next. Unsettled regulatory status for some upcycled ingredients in certain markets. And a consumer perception problem that's proven stubborn. A lot of people, handed a product made from what they know used to be brewery trash, still need convincing that upcycled doesn't mean lesser. Both companies are, at heart, racing the same 24 to 48-hour clock, just at different scales and with different tools. Regrain's process starts the moment spent grain leaves the mash tun. The wet, warm material has to be collected and stabilized before microbial spoilage sets in, using the thermomechanical treatment developed with the USDA. Heat and mechanical processing combined in a way that locks in the grain's nutrition and dries it down to a shelf-stable state without needing refrigeration afterward. What comes out the other end looks nothing like brewery waste. A fine, tan-colored flour that can sit in a warehouse at room temperature, ready to be milled further, blended into a recipe, or extruded into a snack bar. Beyond Regrain's own flour and snack puffs, other companies have pushed the same base material into pet food. Brands like Brewskits and Portland Pet Food Company turn it into dog treats, while Rise Products sells both wholesale flour and its own packaged baked goods built on the same rescued grain. Because the process happens fast and the ingredient is shelf-stable afterward, Regrained can source grain from breweries that would otherwise have no realistic way to move a fast-spoiling byproduct before it turned into a disposal problem. Evergrain runs a version of the same race at a completely different scale, built directly into Anheuser-Busch InBev's own industrial supply chain, rather than sourced brewery by brewery. Because the company already owns the breweries generating the spent grain, it can move raw material into processing on a predictable, captive schedule, instead of coordinating pickups from dozens of independent breweries, turning a chronic logistics problem into a routine, in-house production step. The extraction itself relies on natural enzymes that split the grain into its long-chain proteins, its fiber, and everything else, pulling each fraction apart cleanly, rather than trying to dry and grind the whole byproduct at once. The result is EverPro, a concentrated plant-based protein ingredient sold not directly to consumers, but to other food and beverage manufacturers, who blend it into products like protein bars and plant-based milks that never mention beer at all. Neither process, however, comes close to touching most of the world's spent grain. The 38 to 40 million tons generated globally every year still overwhelmingly follow the two original exits: feed where a farm is close enough to take it, landfill where one isn't. Upcycled human food ingredients remain a small, high-value niche, carved out of the edges of a much larger disposal problem, not a wholesale replacement for it. Even the animal feed route that still absorbs the bulk of usable spent grain comes with its own ceiling. At roughly 71 to 75% total digestible nutrients, and a safe dietary cap of around 20% for lactating dairy cows, it was never going to be a complete answer to 38 million tons a year on its own. Merely the least bad option available before anyone found a faster one. The bet these two companies are making reaches further than flour and protein bars. Every ton of spent grain that gets turned into a shelf-stable ingredient instead of a landfill delivery is a ton that never breaks down anaerobically into methane. And landfills, as a category, are responsible for roughly 18% of the world's human-caused methane emissions, the third largest source after fossil fuels and livestock digestion itself. Diverting organic waste like spent grain away from landfills and into composting, animal feed, or human food is one of the more direct ways to shrink that number, without requiring a single new piece of climate technology. Just faster logistics on a byproduct that already exists in enormous volume every single day. It also sits inside a broader shift the food industry has been making toward upcycled ingredients, products built specifically from material that used to be discarded, verified and labeled through organizations like the Upcycled Food Association, that both Regrain's and Evergrain's ingredients have been certified under. Spent grain is an unusually good test case for that whole category, precisely because the volume is so large and so concentrated. Unlike diffuse food waste scattered across millions of households, spent grain is generated in large, predictable batches at a small number of known locations, breweries, which makes it one of the more tractable waste streams to actually intercept before it's lost. Food is not even the only second life spent grain can have. Researchers have shown the same byproduct can be run through biogas digesters to generate energy, pressed into particle board as a lignocellulosic building material without needing added synthetic binders, worked into bricks to increase porosity and improve insulation, and processed into disposable trays. None of those routes is scaled anywhere near what Regrained or Evergrain have built for food-grade ingredients, but they widen the same underlying bet. A byproduct this abundant, this predictable, and this concentrated at a small number of known sites has value running in more directions than any single company is chasing at once. That pressure isn't only coming from corporate sustainability goals. In California, a state law known as SB 1383 aims squarely at short-lived climate pollutants like methane, now requires diverting 75% of the state's organic waste away from landfills by 2025, measured against 2014 levels, with businesses required to separate organic waste rather than simply trashing it. A byproduct that used to be a brewery's problem to quietly dispose of is, in a growing number of places, becoming a byproduct breweries are legally required to find a better answer for. The broader upcycled food category that spent grain sits inside has grown into real money, not a niche curiosity. Estimates put the global upcycled food products market at somewhere between $59 and $62 billion in 2023 and 2024, with projections reaching well past $100 billion within the next decade. The Upcycled Food Association, the certification body behind both Regrain's and Evergrain's ingredient lines, estimates its certification program alone has kept more than 840 million pounds of food waste out of the system annually across its full portfolio of certified products. Run the numbers from both ends, and the shift is concrete, not aspirational. Regrained went from two friends manually hauling tubs of wet grain out of a home kitchen to a company with a patented USDA-co-developed process, the world's first upcycled food certification, a $2.5 million strategic financing round backed by an ingredient supplier and an arm of one of the largest pasta companies on Earth, and a Forbes 30 Under 30 recognition for its founders, all built on an ingredient that started as something breweries used to pay to throw away. Regrain's own trajectory shows the scale-up in plain numbers. The company rescued roughly 50,000 pounds of spent grain in one early year, then more than 400,000 pounds in 2020 alone, with plans to push past 1 million pounds the year after that, a startup's rescue volume climbing by roughly 20-fold in just a few years. Evergrain went from a research center idea inside Anheuser-Busch InBev in 2013 to a certified commercial ingredient line in market by 2021, built to process a meaningful share of the 1.4 million metric tons of spent grain the company's own breweries generate every year. Grain that used to be, at best, a feed delivery and a logistics headache, and is now a certified food-grade product line sold to other manufacturers. Evergrain has since partnered with Bright Future Foods to put its ingredient into a line of snacks marketed as climate positive. Spent grain, twice removed from the original beer, showing up on a snack aisle shelf under its own claim about the planet, not just about taste. EverPro itself now shows up under other companies' names entirely, in a barley-based plant milk called Take Two, in crackers made with Post Holdings, in Nestlé's Garden of Life nutrition line, and in a non-alcoholic beer from Athletic Brewing, with Evergrain reporting solubility and digestibility that match or beat whey and pea protein, the two ingredients it's most directly competing against on a supermarket shelf. Neither company has come close to processing all 38 to 40 million tons the world's breweries produce annually. But both have proven the same underlying fact. Given a process fast enough to beat a 24 to 48-hour spoilage clock, spent grain isn't spent at all. Spent grain never stopped being nutritious the moment it left the mash tun. It was always full of protein and fiber. The only thing that ever separated it from food was time, and nobody had built a process fast enough to use before the clock ran out. That's a strange thing to sit with, an industry-wide disposal problem that persisted for centuries, not because the material was worthless, but because beating a 24 to 48-hour window took the right combination of curiosity and resources showing up at the right moment. It took two homebrewing friends hauling plastic tubs out of a kitchen, and it took the internal research arm of the largest brewing company on the planet, spending 7 years on the same underlying bet, arriving independently at the identical conclusion. Neither the biggest company in the industry, nor the smallest team in it, had a monopoly on noticing what the clock was actually protecting. Researchers studying the wider potential of spent grain protein have started framing it in even higher stakes terms than snack bars and pasta. Because it's generated predictably, in enormous volume, at a relatively small number of known locations, some see a real opening to fortify humanitarian food aid in parts of the world facing chronic malnutrition, using a protein and fiber source that already exists in surplus, rather than one that would need new farmland to grow. Whether that potential gets built out at scale remains an open question, but it reframes spent grain from a beer industry curiosity into something closer to an overlooked global nutrition resource that happened to be sitting in a mash tun the whole time. There's a strange historical symmetry underneath all of this. For most of human history, baking and brewing weren't separate industries at all. They were the same household craft, often practiced by the same women, using the same grain. Ancient Sumerians brewed beer from a twice-baked bread called bapir. Egyptians brewed with the same emmer wheat and barley that filled their loaves. And archaeologists still debate which came first, the bread or the beer, because for thousands of years there was barely a difference. Industrial-scale brewing is what finally split the two apart, turning what used to flow naturally from grain to bread and grain to beer in the same kitchen into two separate industries, one of which now throws away, every year, a byproduct that used to just become someone's next loaf. If stories like this, where the thing everyone already assumed was garbage turns out to still be full of value, if someone moves fast enough to catch it, are what you're here for, subscribe, because next time we're looking at a different byproduct that spent just as long being thrown away for no good reason.